Okay, next step is to replace the line of code with this byte duplication right here with more or less a normal looking set of instructions, and these are the move instructions. So since we're going to modify the program, I'm just going to say debug, stop debugging. Okay, and we take this set of move instructions and replace this, right? Or we can just comment it out like this, I guess, and insert new set of instructions. So these instructions, basically what they specify is that we have the label identifying a location of this character or this byte in our memory. And then we say that we would like to go to this memory and store new value there, the character literal x. So notice, just like in C program, you can still use character literals with single apostrophe notation, single quotes basically, right? And so what is going to happen, of course, the direction of move is this way. So basically it's this way. It's going to store a new value. This character x will be stored replacing character A. Of course, using square brackets indicates that we're trying to move something into memory. So remember, that's how you know. The square bracket notation indicates that inside here, okay, this is an address of apparently character. And we can be explicit. We can say that characters is a pointer to a byte. Okay, so this is the explicit operator pointer, which specifies what kind of pointer. Pointer to byte, pointer to double word, that would be an integer. In our case, it's just a single byte. So this literal character x is going to be stored at this address, and the type of instruction that we need is just to replace one byte with this new value. Okay, so that's what this does. Then, of course, we say now we want to go characters plus 1 and then characters plus 2, and you see that we're replacing ABC characters with XYZ. So this is just a move instruction here. So let's rebuild like this. It's quite simple what we have, and we can now restart in debug mode by pressing F11 to simply step into. F11 launches a debug session for our program here. I'll just close this memory view and immediate window for now. I'll close these two and close the registers to keep just a simple view. And let me just move my, or rather I can expand a little bit this window just to show all the parts of the move instruction that I have here. Okay, so let's see. Copy and paste the move commands from this assembly window into the space below. So let's do this. So these are our 3 move instructions. Of course, this indicator tells us that this is the next instruction to execute. I just press Ctrl C and copy it right here. Okay, so that's what we get with respect to the program built from this sequence right here. What kind of information does the disassembly window display? Describe addresses, byte codes, command mnemonics, and command operands. Okay, so let's take a look at this, and I'll just try to highlight it for you. So of course these are addresses of characters in the code memory segment, right? So we have our program in memory. Part of it is data, part of it is code. And these addresses essentially point to some place in the code memory segment where 3 of these instructions reside in memory. Byte codes. So here are the byte codes of these move instructions. Right. So each instruction has 1, 2, 3, 4, 5, 6, 7 byte codes, basically 7 byte long instruction move, and the X, the Y, and the Z encodings are hexadecimal 58, 59, and 5A. So these are immediate values that are quite visible, and these characters are not stored in memory, right? You can actually see them here being replaced, 58, 59, and 5A hexadecimal. So these are the byte codes, and of course the first byte here is the operation code. I have no doubt about that. So it indicates this is the move instruction, and it's using a second byte to specify what kind of operand addressing mode there is. To be able to find out what this is, we have to look up in the manual, but not in this answer. We just provide very general description of what we see. So address, the code bytes right here. Right? So this is what we can see in this set of code bytes. These are of course command mnemonics, and this is a move instruction. So move instruction is like an assignment, basically characters equal whatever, X, right? So characters equal X. So that would be the pseudocode example in a C programming language. So this is assignment in a high-level programming language, kind of corresponds to the move instruction in the actual CPU. And then, so these are our operands. Okay, so let's make a little bit of an adjustment here. I mean, I just want to space it so that it becomes aligned like this, right? It doesn't matter, just white space. So of course we know that characters XYZ are these codes, but these are the operands in memory. Basically, this is the label in terms of command operands. So move has 2 operands, and one of the operands on the left hand side, the target, uses square brackets which indicate that this is a memory location, and characters is actually characters label that we had in our program right here, characters label at runtime. Let me just resize this because now we already have the disassembly copy right here, right? So this the characters label now becomes an actual physical address like this. Okay, so this characters label becomes an actual, but the executable image does contain debug symbols, and disassembler is smart enough to look up debug symbols in our in the binary image of our program or in supplemental file placed in the same directory, and it finds out that this address corresponds to characters. And see how it's not that smart. As soon as we add +1, it kind of loses the idea that it really doesn't find any variable at this location +1, so it just reverts to default memory address, not prompting that this is characters +1. So it's just, remember, this disassembler doesn't know that this file exists. It doesn't have access to this file. All it does is basically just trying to grab what it finds here, these opcodes, right, and trying to understand what kind of instruction and what it could potentially access in our memory. So yeah, so the bottom line is that the move instruction has 2 operands. One is the source, and the second one is the target. In our case, these are called immediate operands, right? So when things are literally specified part of the instruction, they become embedded in the instruction, right? So as we can see, there they are, right? So these are XYZ are stored directly in the code segment. It's part of the move instruction itself. It's called immediate operand. Immediate because as soon as instruction move is loaded into the instruction register for execution, these values immediately become available to the hardware. There is no need to do another hop into memory somewhere to find the value. It's available instantly because it's already part of the instruction itself. So that's the meaning of the immediate operand.